Students, welcome to the review sheet help class. Couple quick announcements. I've emailed all of you and told you to listen to the first so many minutes of this video. First of all, I want you to understand when you come to class Monday, you need to have your answer ready. Well, let me back up. I'm getting paid to do a job, and I want to do a good job. And having said that, I don't want anyone to think I'm getting out of work, but I want to make this easy for you also. My door is open Monday. I'm looking forward to meeting some new students and seeing the old students. However, if you go through this review sheet and you're like, wow, I get it. And really, to be honest, guys, it shouldn't be that hard. It's a review chapter. And you're like, I don't need to go to Mr. Earhart's house Monday for help. And I really don't mind taking the test at my house because it's just not difficult for me. Feel free not to come. There's nothing wrong with that, okay? So that's number one. Number two, if you are not coming Monday, would you email me or call me and let me know? Because what if all four do that and then I'm sitting here waiting for someone to show up? Next, I'm assuming some will come, and I hope so. Okay, again, I'm not trying to get out of work. I just want you guys to be able to do what's best for you. And some of you need to meet with me. Others of you might not need to. So next, if you're coming, you need to know when you walk in the door whether you're going to take the test. Right then, hey, Mr. Aaron, I'm ready for the test. Or some of you might say, there's no way I'm taking that test. I'm going to spend the whole time going over the review sheet. Or some of you might say, hey, I'm going to ask questions for 15, 20 minutes. I've only got 2 or 3 questions. Then I'm taking the test. All of that is up to you. The door is open to whatever you want. All that I ask is before you get here, know what you want so you can communicate it to me, okay? Don't show up and look at me like I'm going to be able to tell you. This is a decision you've got to make, okay? And then also, you might want to tell your parents, hey, well, I know one student, Caleb, lives close by, and he could probably walk home from here. And you might come for 30 minutes or an hour, some of you, and then call your parents and say, hey, come get me, I'm ready to go. That's fine. All of that is up to you, okay? But what I have set aside for you is Monday, 8:30 to 10:30. Now, one of you told me you might not be able to get here at 8:30, a little bit after. So if that's the case, if that one student wants to stay a little bit past 10:30, no problem. No problem whatsoever. But as soon as this class is over, as soon as this class is over, I have to start homeschooling my 3 boys, okay? And at 10:30 start is a pretty late start, so I do want to start right on time or pretty much thereafter. So there you go. If you have any questions, email me or call me. But if you're not coming, let me know that. Be polite. And if you are, when you show up, know what you're going to do. All right? Having said that, now let's jump into this video, and hopefully this will help you understand the problems. Okay, on numbers 3 through 8, we're finding the domain. And what I taught you to do was take the denominator, okay? In this case, it's x parentheses x minus 1, and say to yourself, what would make this denominator become 0? Now, not always, we want to try to factor. We can't always do it, but we want to try. Now, on this problem here, you can't factor. I mean, here's an x outside the parentheses. Nothing you can do with that. Look inside the parentheses. We have a binomial. Do you know the square root? Remember how to factor binomials? We talked about this. You have to know either the square root or the cube root of these 2 terms. And we do not know the square root or the cube root of those 2 terms. So you really can't factor this. So what we do is we look at this group here, and we say to ourselves, what would make that group become 0? Well, just a 0. If you put a 0 in for x right there, then the whole thing would become 0. And now look at, so there's a 0, put a 0 down here. Now look at this group. What would you put in for x that would make this parentheses become a 0? Wouldn't it be a 1? Because 1 minus 1 is 0. So there's another number that x cannot be. So what is the domain? Domain equals all real numbers such that, should be an apostrophe, such that x cannot equal 0 and 1. There you go. That's it. You just found the domain. All right, number 4. Let's take our denominator. Again, there's no factoring to do here, students, okay? There's no factoring. You cannot factor 2x and we cannot factor this binomial. We do not know the square root or the cubed root of either one of these two terms. So we say to ourselves, what would I put in for x that would make that group a 0? Well, 0, because 2 times 0 is 0. So what I would put in for x right there to make this group 0 is 0. So there's one number that x cannot be. Now this one's going to be a lot harder. Look, students, if it was just x minus 2, then obviously the number you would put in for x to make this parentheses become 0 would be 2, because 2 minus 2 is 0. But some of these you really can't do in your head. So it's going to be a fraction, by the way. So if you can't do it in your head, then just take the parentheses like this, set it equal to 0, and solve. Add 2 to both sides. So we have 3x equals 2, and then divide both sides by 3. And when you divide both sides by 3, you get 2/3. So there's another number that x cannot be. So in other words, what number would you put in for x right here that would make this whole parentheses become 0? 2/3. If you put 2/3 in for x, trust me, 3 times 2/3 is 2, and 2 minus 2 is 0. So x cannot be these two numbers, so you would say the domain is all real numbers such that x does not equal 0 and 2/3. 0, 2/3. All right, moving on to the next one. Now we're going to have to factor this denominator. So we have x squared plus 4x minus 5. Now, we're going to find out what the domain is. Well, first of all, we're going to factor this. Pull out what's common. There's nothing common we can pull out. Next, look at what you have, a binomial or a trinomial. Well, we have a trinomial, okay? Does it have a lead coefficient of 1 or not have a lead coefficient of 1? Well, it has a lead coefficient of 1. That's the easy kind. So we're going to list out all the multiples of -5. So 1 times, or all the factors of -5. So 1 times 5, 1 times 5. Positive times a negative, negative times a positive. One of those groups adds up to +4. It's that group right there. So we go ahead and put our two parentheses, and the factorization would be x minus 1, x plus 5. Now, what would you put in for x for this parentheses to make this parentheses 0? 1. And what would you put in for x to make this parentheses 0? -5. Because 1 minus 1 is 0, and -5 plus 5 is 0. So your domain would be all, fix that, all real numbers such that x does not equal 1 and -5. There we go. Number 6. Now, be careful here. This first parentheses, x plus 2, cannot be factored. It's a binomial, and we do not know the square root or the cubed root of these two terms. But look at your second parentheses. Look at this. It's a binomial. We do know the square root of this term. We do know the square root of that term. And whenever you're dealing with perfect squares, the first term has to be positive, and it is. And the second term has to be negative, and it is. So the first parentheses I can do nothing with. But the second parentheses, I know how to factor that. Remember, we take the square root of this, which is x, so I put an x here and an x here. We take the square root of this term, 1, which would be 1, so a 1 here and a 1 here. That's supposed to be a parentheses right there. And then we make one positive and we make one negative. So for this parentheses here, what would we put in for x that would make this parentheses 0? -2. What would we put into this parentheses here to make the parentheses 0? -1. And what would we put into this parentheses here to make the parentheses 0? 1. So those three numbers are numbers that x cannot be, because these three numbers make the whole denominator become 0. So the domain would be all real numbers such that x cannot equal, put a slash, cannot equal -2. And I'm going to put plus minus 1. That's a fast way of putting positive and -1. If you want to write it out a long way, that's fine, but that's number 6. All right, let's go ahead and move on now to number 7. Okay, well, I'm not going to rewrite this whole denominator. I'm just going to work from right here. First of all, I have a parentheses right here, and notice I have a binomial inside. I do know the square root of this term. I do know the square root of that term. So I'm dealing with perfect squares. Notice the first term is positive, the second term is negative. So I can take this first parentheses right here, that first parentheses, and I can break it down into two little parentheses like this. What's the square root of x squared? It's x. So I put an x here and an x here. The square root of 4 is 2, so I put a 2 here and a 2 here. I make one positive, I make one negative. Now let's look at our trinomial right here, okay? Is it a trinomial with a lead coefficient of 1 or a non-lead coefficient of 1? Well, I have a 1 here, so I have a lead coefficient of 1. So I'm going to list out all the factors of negative 10. So 1 and 10, 1 and 10, 2 and 5, 2 and 5. Notice it's a negative 10, so I want a positive times a negative and a negative times a positive. And a positive times a negative, and a negative times a positive. Now one of these adds up to a positive 3. See your middle term right here? A positive 3. And so this one adds up to a positive 3. So I'm going to go ahead and put for the factorization x minus 2, x plus 5. Now, notice two parentheses are the same, so you're going to get out the same number twice. You don't have to write that number twice. Just letting you know. So what number would make this parentheses a 0? Negative 2. What number would make this parentheses a 0? 2. What number would make this parentheses a 0? 2. And what number would make this parentheses a 0? Negative 5. So these are the numbers that x cannot be. There's no need to write the number 2 twice, so I'll cross that off. And here's your domain. All real numbers. In other words, x can be anything such that x does not equal plus, minus 2, and negative 5. There we go. All right, that's what x cannot, or that's what x can be. All real numbers except those three numbers. All right, number 8. I have an x right here at, on the outside of the parentheses. I really can't factor an x. There's nothing I can do but a trinomial right here. And it's the easy kind, lead coefficient of 1. So that's pretty good. List out all the factors of 6. So 1 times 6, 1 times 6, 2 times 3, 2 times 3. It's a negative 6, so a positive times a negative. Negative times a positive, positive times a negative, negative times a positive. One of these adds up to your middle term. There's no number here, but we know there's really a 1 there, even though we can't see it. So we have a negative 1, and this group here adds up to a negative 1. So my final factorization would be x, and then two parentheses for this trinomial, x plus 2, x minus 3. Now what would make this group right here? What would make that group a 0? 0. What number for x would make this group a 0? Negative 2. And what number would make this group a 0? 3. So these are the three numbers that x cannot be. So your domain is all real numbers such that x does not equal 0, negative 2, 3. Okay, that's numbers 3 through 8. That's the first section of the review sheet, finding domains of rational expressions. Now let's move on to numbers 9 through 14. The directions for 9 through 14 state to simplify. Now, on the test, I hope no one does this, but I could see students saying, oh, dude, cool. Cross off an x squared, cross off an x squared. Here's a bunch of 4s. Cross all those things off, and we're left with 1 over x. You know, that is completely wrong. You cannot just start crossing things off unless you have one term up top in the numerator and one term in the bottom, the denominator, and we don't. We've got 2 terms up here, 1, 2. We got 3 terms down here, 1, 2, 3. We're not even close to that. So what we have to do is factor the top and factor the bottom, okay? So let's look at the top first of all. The top's pretty easy. Notice I have a binomial, and I know the square root of this term. I know the square root of this term. The first one's positive, the second one's negative. So I'm dealing with perfect squares. When you're dealing with a binomial of perfect squares, you write 2 little parentheses. The square root of this term would be x, so I put an x here and an x here. The square root of this term would be a 2, so I put a 2 here and a 2 here. Make one positive, make one negative. Booyah, we're done with that. All right, now we come down to this trinomial. Notice I have a lead coefficient of 1, so that's the easy type of trinomial. So I list out all the factors of positive 4. So 1 and 4, 1 and 4, 2 and 2, 2 and 2. I want a positive 4, so a positive times a positive. negative times a negative, positive times a positive, negative times a negative. One of those adds up to a negative 4, which is your middle term, and that would be this group right here. So my factorization would be x minus 2, x minus 2. Now we're trying to simplify the fraction, so notice this parentheses here would cancel with this parentheses here, and there's your final answer, x plus 2 over x minus 2. Not too bad. That's number 9. Okay, number 10. Well, we do not have one term up top and one term in the bottom, so we're going to have to do some factoring. Okay, let's start with the numerator. The numerator is a trinomial. There's nothing common I can pull out. And so I notice I have a trinomial with a lead coefficient of 1, which is the best kind. So I'm going to list out the factors of negative 3. So 1 times 3, 1 times 3. Make one positive, negative, negative times a positive. And only one of these adds up to a positive 2. It's that right there. So my factorization for the numerator is going to be x minus 1, x plus 3. Now the denominator is a binomial. Okay? There's nothing common I can factor out, so I say to myself, am I dealing with perfect squares or perfect cubes? Well, I know the square root of this term and the square root of this term, so I'm dealing with perfect squares. When you're dealing with perfect squares, the first term has to be positive, and it is, and the second term has to be negative, and it is. So we're ready to factor these perfect squares. The square root of x squared is x. Put an x here and an x here. The square root of this term is 3. So I put a 3 here and a 3 here, make one positive, make one negative. See this x plus 3 and this x plus 3? They cancel out. So the final simplified version of this fraction, that fraction right there, reduces to x minus 1 over x minus 3. What you're doing, students, is no different than having 8 over 12 and reducing it to 2/3, because 4 goes into 8 2 times and 4 goes into 12 3 times. That's all you're doing. You're just simply reducing a fraction, only instead of having numbers, you have variables. All right, let's go ahead and move on to number 11. Okay, well, let's start with the numerator. First of all, it looks like I can pull an x out. I'm going to do that off to the side here. I can't pull any numbers out because I have a 1 here. A 1 is 6 and a 9, so, but I can pull an x out. And if I pull an x out, I'm going to be left with x squared minus 6x plus 9. All right. Now, look what I'm left over with inside my parentheses. A trinomial with a lead coefficient of 1. Do you see that okay? So, actually, I think I'm really doing this in a sloppy way, and I apologize. We're going to be doing a lot of factoring on this problem, so let's just do this. Let's take the numerator right here, and I don't think I can cut and paste. No, I cannot do that. Okay. I'm just going to take the numerator and put it over here, x squared minus 6x plus 9, and then continue going down. Let's list out all the factors. Notice I have a trinomial with a lead coefficient of 1 right here, so I'm going to list out all the factors of 9. So 1 times 9, 1 times 9, 3 times 3, 3 times 3, it's a positive 9, so I want positives and negatives going together like this, and only one of these adds up to a negative 6. It would be these two numbers right here. And so my final factorization would be bring down your x, and then you would have x minus 3, x minus 3. All right, so I'm going to come back up here now, put an arrow, put my fraction bar, and I'm going to go ahead and put x minus 3, x minus 3. All right, now to give me some room, I'm going to go ahead and erase all this, so you can always back the video up if you need to. Now let's look at the denominator. All right, first of all, I see that I can pull an x squared out of both terms. So I'm going to factor out an x squared, and that leaves me with x minus 3. Well, students, look, you cannot factor this binomial. If you want to factor this binomial, you have to know either the square root of both of these terms or the cubed root. And we do not know the square root of both of these terms or the cubed root. So you cannot factor this parentheses any further. So I'm going to come over here and I'm going to write x squared and then parentheses x minus 3. Now look what cancels. First of all, you've got an x minus 3 and an x minus 3. And then look, you have one x right here, this x to the 1 power. You've got two x's here. Let's take an x away from the top. Let's take 1 away from here, and you're left with 1. And now there we go. There's nothing else you can reduce. X minus 3 over x. Please don't try to do this. Please don't try to cross off your x's. That's wrong. This is a binomial. This parentheses pulls them together. If you're going to simplify x minus 3, you must have a parentheses down here that says x minus 3. You cannot just cross these x's off, okay? So that is our final answer, and we have simplified it. Moving on to number 12. Okay, let's start with the numerator. I'm looking. I have a 1, a 5, and a 4, so I cannot factor out any numbers. But my variables, I have 5, 4, and 3. So I can factor out 3 y's, and that would leave me with y squared minus 5y plus 4. Okay? And now I'm left over with a trinomial here that does have a lead coefficient of 1. So I'm going to list out the factors of positive 4, and that would be 1 times 4, 1 times 4, 2 times 2, 2 times 2, and then positive times a positive, and negative times a negative. And by the way, students, before this video is over today, I'm going to quit listing these out, and I'm just going to show you the one that works. I've done this so many times now. You guys really should be able to do this on your own and pick the right one. So I'm just going to start showing you which one is the right one without listing all of these out. But anyways, one of these groups does add up to a negative 5, and it's that group right there. So I bring down my y cubed, and then my factorization would be y minus 1, y minus 4. Does everybody see that okay? I hope so. Now, I'm going to come up here and slide this fraction over. Give me some room. Put a little arrow here. Now let's put a big fraction bar. That's not a very good. All right. Now, this is the numerator. I just showed that to you. So if that's our numerator, let's go ahead and pull that up to the top if we're able to do that. There we go, up top. All right, now let's go ahead and factor the denominator. When I look at the denominator, I'm seeing 3 y's, 2 y's, and 1 y. There's no numbers I can pull out, but with letters or variables I can pull out a y, and that leaves me with y squared minus 6y plus 8. Notice I'm left over inside the parentheses with a trinomial that does have a lead coefficient of 1. So if I listed out all the multiples of 8, positive 8, and then tried to find a group that was a negative 6, it would be a negative 2 and a negative 4. These two numbers, when you multiply, get a positive 8, and when you combine them, you get a negative 6. Did you notice this time I did not list out all the factors and take all that time? From now on, I'm just going to show you which factors we would use. So the two numbers that would work would be negative 2 and negative 4, so bring down your y, and then we'd have y minus 2 and y minus 4. And that is the factorization of the denominator. All right? So let's pull that up here, and now let's see if we can't do some simplifying. Y minus 4, y minus 4. Okay? Now, obviously, students, look, the y minus 1 and the y minus 2 are not going to cancel with anything. They're groups. They're in parentheses. You cannot cross off of this y with this y. Okay? Do not do that. You will miss the problem. However, I do have some y's on the outside that are in their own groups. I have 1 y here and 3 y's here. I can take 1 y away from the bottom, take 1 y away from the top, and that would leave me with y squared. So don't forget your parentheses around the top. I can do better than that. There we go. And then this y squared would be right here on the outside of your parentheses in the numerator. All right, so there we go. And yes, you do need these parentheses because you have a variable on the outside. Okay, let's take a look at number 13. Number 13. Okay, first of all, when I look at the numerator, I notice right away there are no y's I can factor out, but there's a 6 I can factor out. So I'm going to pull out a 6, and I'm left with y squared plus 2y minus 8. Okay? And now look what I'm left over with inside the parentheses, a trinomial that has a lead coefficient of 1. So if I listed out all of the factors of negative 8 and tried to match up with a positive 2, it would be a negative 2 and a positive 4. If you multiply those two numbers, you get a negative 8. And if you add those two numbers, you get a positive 2. So those are the two numbers we want to use. So 6 parentheses y minus 2 parentheses y plus 4. All right, let's move this over a little bit. And so our numerator has now factored to this. All right. Now let's take a look at our denominator. First thing I notice is you can factor a 3 out of everything. So pull out a 3, and you're left with y squared minus 3y plus 2. Next, I noticed I'm left over with a trinomial with a lead coefficient of 1. So if I listed out all the factors of -2 and seen which one added up to a -3, it would be this group right here. If you multiply these two numbers, you get a +2. If you combine them, you get -3. So bring down your 3, and then we have x minus 1, x minus 2, x minus 1, x minus 2. So this is now the factorization of my denominator. Let's pull it up here. Now, obviously, I think I used x's down here, and I apologize. I mean, obviously, look, we're dealing with y's, right? And that's my fault. I'm sorry. So this should be y minus 1, and this should be y minus 2. Okay, notice my y minus 2 right here would cancel with my y minus 2. There's no way your y plus 4 and your y minus 1 are going to cancel, but you've got a 3 and a 6. They're whole numbers. You know how to cancel whole numbers. 3 goes into 3 once, and 3 goes into 6 twice. So your numerator is 2 parentheses y plus 4, and your denominator would be 1 parentheses y minus 1. Now, do you have to put this 1 on the outside? No, you do not. If you wanted to just put y minus 1 like this, that's totally fine. If you want to put the parentheses and put a 1 on the outside, that's totally fine. No preference, all right? All right, one more problem in this section. We'll move on to the next pages on our review sheet. Okay, when I look at the numerator, I realize there are no x's I can pull out, but I can factor out a 2. So I'm left over with x squared minus 10x plus 25. All right, notice I'm left over with a trinomial with a lead coefficient of 1. So if I listed out all the factors of 25 and tried to find a group that combined to -10, I would get -5 and -5. So bring down your 2, and then parentheses x minus 5, x minus 5. All right, let's pull up our numerator here. Now let's take a look at our denominator. First thing I notice about our denominator is we can pull a 10 out. So we pull out a 10, we're left with x squared minus 3x minus 10. Notice I'm left over with a trinomial that has a lead coefficient of 1. So I'm going to list out all the factors of -10 and look for a group that combines to -3. And I'm pretty sure that's going to be a +2 and a -5. If you multiply those, you get -10. If you combine them, you get -3. So bring down your 10, and then we would have x plus 2 and x minus 5. All right, so let's move this over to our denominator, and let's start canceling. X minus 5 cancels with x minus 5. I have a 2 and a 10. 2 goes into 2 once, 2 goes into 10 5 times. So in my numerator, I have x minus 5. That's good enough. If you want to put the parentheses and put a 1 on the outside, I have no problem with that. In the denominator, we have 5 parentheses x plus 2. Okay, there we go. That's the answer to the first section. Let me skim up to the top of the pages here. We're going on now to pages 52 and 53. All right, pages 52 and 53. Okay, students, we're now going to do numbers 5 through 11 on page 52. And here we go. It says for numbers 5 through 11, consider, or 5 through 10, 5 through 11, consider the following numbers. And here's the numbers right here they've given to us. Excuse me. Which one are the integers? I'm going to circle them for you. Remember, integers are whole numbers, positive and negative, which of course would also include 0 because 0 is a whole number. So my integers would be, I'm going to circle them, then erase. I'm not going to write all the numbers down here, okay? So number 5 would be integers. 12 is an integer. -3 is an integer. -1 is an integer. -19 is an integer. 31 is an integer. And 0 is an integer. Okay, so there are your integers. Moving on now to number 6. Number 6 says, which are the natural numbers? Now, natural numbers start at 1 and go to the right. So 1, 2, 3, 4, and they're whole numbers, not decimals, fractions, etc. So 12 would be 1, negative 3 would not. Think of a number line. Here's 0, here's 1, here's 2. Natural numbers start at 1 and go this way, of course not counting fractions and decimals. So 12, 31. 0 is not a natural number. So we're looking at just 12 and 31. All right. Which one are the, now we're looking at number 7. Which ones are the rational numbers? Now, rational are the terminating, repeating, or the whole numbers. This one terminates. It stops right at 0.89. Let me say that again. Rational numbers are integers and then fractions that repeat or terminate. Well, this terminates. This is an integer. This is an integer. If you type in 1/5 into your calculator, you'll get 0.2. It terminates. This does not terminate. This does not terminate. This is an integer. This repeats. Negative 1.333, so that's fine. This repeats. 7.666666, so that's fine. Negative 19 is an integer. 31 is an integer. And 0 is an integer. So all of those numbers are rational numbers. Okay? Again, rational numbers are integers and repeating and terminating numbers. All right, let's continue on to number 8. Which one are real numbers? Number 8, which ones are real numbers? All of them. Real numbers are all of the numbers in our number system except for imaginary numbers, and we've not gotten into that yet this year. Okay, number 9, which are the irrational numbers? Well, think about it. That was rational. We said that was rational. That was. All these numbers I'm crossing off, we said were rational in number 7. And so the only two left are my irrational numbers. So these two numbers here are my answers to number 9, my irrational numbers. And by the way, if you type in the square root of 7 into your calculator, you will see it does not repeat and it does not terminate. If you type in the cube root of 10, you will see it does not repeat and it does not terminate. Okay, let's move on to number 10, which are the whole numbers. Which are the whole numbers? Well, whole numbers, now remember, think of a number line. Whole numbers start at 0 and go this way, not counting decimals and fractions. So 0 and to the right. So this would be a whole number. That's not. None of these are. Negative 1 is not. It has to be to the right of 0 and a whole number. That's not. This is a whole number, and 0. Now 0 is not a natural number, but 0 is a whole number. So those are the whole numbers, and that was number 10. Now I know number 11, I gave it to you accidentally, and I know it won't be on the test, but I'm going to go ahead and answer it for you. Write in interval notation. Now here's what we have. We have negative 3. This is just free of charge. If you want to fast forward this and not listen to it, fine. If you do, that's fine. We're going to learn this later this year. Here's negative 3, and here's 5 way over here on the number line. X is greater than or equal to negative 3, so I go this way, and it's less than 5 there. How to write that in interval notation? Since this is equal to negative 3, you put a bracket and you put a negative 3 and then you put a comma and then you put the number where this conjunction ends. It started here, it ends here at 5, so you put a 5, and because it's not equal to 5, this is not colored in like this was over here, then you put a parentheses, and that's called interval notation, and I accidentally gave you number 11, so let's go ahead and move on. Don't worry about that. All right, let's take a look now at number 12, or number, excuse me, let me quickly scroll up and look at the assignment. We had to do what, 5 through 11, and now 17 through 24, so 17 through 24. Okay, number 17 is pretty simple. Write this from scientific notation to standard notation. Here's my decimal. Notice it's a positive 6, so I'm going to move the decimal 6 places to the right to get a bigger number. So 1, 2, 3, 4, 5, 6. I'm going to have to add 3 zeros. So 3, 2, 6, 1, and then 3 zeros. So my answer is 3,261,000. Notice on number 18 I have a negative 4 for my exponent. So I'm going to take 4.1 and I'm going to move the decimal not to the right, not that way, but I'm going to move it to the left 4 places. So 1, 2, 3, 4. I'm going to have to put in 3 zeros, so 0.00041, and that is the proper standard notation for number 18. All right, let's move on to number 19. Now number 19, they're giving us the problem in standard notation, and we're going to write it in scientific notation. Here's your decimal right here. We're going to move it until we have 1 digit to the left of the decimal. 1, 2. Now we stop here because we really don't count. Let's go back. You might think we should stop here because we have a 0 right here, but a 0 doesn't count. When I say 1 digit to the left of the decimals, we're not talking about zeros because the idea of scientific notation is to get rid of having all of these zeros, okay? So we're going to move the decimal here, and then stop. So now I have 1.432. You know by now we always put times 10. And I moved it 2 places. Now the question is, do I want a positive or a negative number? Well, think about it. You started off with a really, you started off with a really small number. And whenever you start with a really small number, point something, then it's going to be a negative movement. All right. Now let's take a look at number 20. All right, here the decimal's right here. It's a large number, 43,210, and we're going to move it 1, 2, 3, 4. Now I stop right here because I have 1 digit to the left, so 4.3210 times 10 to the 4th. It would be a positive 4 because the number that we started off with up here was a large number. It was not like a point something number. It's 43,210. And so this would be your scientific notation. We've also learned in the past how to divide scientific notation numbers. Now, the first thing you do when you're dividing 2 numbers that are in scientific notation, you take your calculator and you type these 2 numbers in. 2.5 divided by 3.2. If you do that correctly, you will get now I'm probably rounding. I have this already written down. I believe I rounded. It's 0.78125, and maybe not. Maybe it terminated. But either way, that's good enough. And then you write times 10, and then you subtract these exponents. So your top number goes first, -8, minus, and then you put your bottom number, 13. So -8 minus 13 would be a -21. All right. Now, notice your answer. If you're dividing 2 numbers that are in scientific notation, your final answer must be written in scientific notation. That's just how it is. It's accepted that way. So your decimal's in the wrong place. It must go right here. So you must move your decimal 1 place, 7.8125. And notice when you did, it was a negative movement. Okay, you came from the left to the right. So you're going to add a -1, so like this, plus a -1. That's one way to look at it, or you could just say we're putting a -1 here. Either way, you get a -22. All right, -22. All right, let's move on to number 22. Now, whenever you're multiplying 2 numbers that are written in scientific notation, the first thing you do, and you're welcome to use your calculator, is you type in 8.4 times 6.5. If you do that correctly, you get 54.6. Again, I had this done ahead of time, so I'm not sure if I'm rounding or not. So either I rounded or it terminated. Either way, 54.6, and then times 10, and then you add your exponents. So you have a -17 plus a -16. So -17 plus a -16, and that's a -33. Now, the only problem with your answer is notice it's not written in proper scientific notation. We must move the decimal 1 place. So now we have 5 6.46. And notice when we moved our decimal, we came from the right to the left. That's a positive movement. So if you're at negative 33 and you add 1, you're going to be left with a negative 32. And that is the correct answer. All right, number 22. Let's move on now to number 23. Now, when you're simplifying problems like this on your test, it is understood that your final answer should never have negative exponents. So please remember that. And if you forget that, I will tell you during the test. But first of all, we multiply 7 times negative 2. That would give us a negative 14. And then we have a squared times a to the negative 4. Now, when you're multiplying like bases, a and a, you write the base once and you add the exponents. A positive 2 plus a negative 4 is a negative 2. Now we have b to the 4th times b to the 3rd. When you're multiplying like bases, you write the base once and you add the exponents. Now everything looks great in this problem except this negative exponent. We do not want that a to the negative 2. And by the way, the 14 does not have a negative exponent. The 14 has a positive 1. So it's totally fine. I don't care if the 14 is negative. I just don't want the exponent to be negative. So it looks like to me we're going to have to put a fraction bar, and we're going to have to leave negative 14 b to the 7th up top. But we're going to have to take this a to the negative 2 and move it down to the bottom so that the a becomes a positive 2. And that is the answer. All right, moving on to number 24. Now, what I taught you when you're simplifying these problems is, first of all, go ahead and put your fraction bar. And let's start off with 54 and 9. 9 goes into 9 once, and 9 goes into 54 6 times. So I know I have a 6 here and a 1 here. Now we deal with the variables. When dividing like bases, like this and this, when dividing like bases, you write the base once in the numerator and you subtract the exponents. So 6 minus a negative 3. 6 minus a negative 3. Well, that would be 9. Now let's look at your y's. Y to the negative 4 and y squared. When dividing like bases, you write the base one time up top and you subtract the exponent. So negative 4 minus a 2. Negative 4 minus a 2. Well, that's going to give you a negative 6, and we'll worry about that negative exponent later. Now let's take a look at our z's. When dividing like bases, you write the base once in the numerator and you subtract the exponent. So 2, that's your top number, 2 minus a negative 4. 2 minus a negative 4 is 6. So really, students, everything looks fine except for this negative exponent right here. Z has an exponent of positive 6. X has an exponent of positive 9. 6 has an exponent of positive 1. So all of those look fine, okay? So what I'm going to do is I'm going to put a fraction bar here. I'm going to leave my 6, x to the 9th, z to the 6th in the numerator. And I'm going to take my y to the negative 6 down to the bottom, so I have y to the positive 6 in the bottom. You are more than welcome to put this 1 right here in front of it. You don't have to if you don't want to. That's totally up to you. Okay? That was number 17 through 24. Let's quickly go up to the top of the page again, if you don't mind. And it looks like we also have to do 32 through 45. So let's do that, and we're finally finished. 32 through 45. Okay, on numbers 32, 33, and 34, we are simplifying. So first of all, we take the x times the x squared, x cubed, and then the x times the negative xt, that's a negative x squared t, and then x times t squared. Positive times a positive is positive, and that would give me a positive x t squared. All right, now I'm going to switch colors. I'm going to take this t times x squared. That would give me a positive t x squared, and then this t times negative xt, that would be a negative x t squared. And then a positive t times a positive t squared would be a positive t to the 3rd power. Now let's go ahead and combine like terms. I have an x cubed. I see no other x cubed up here, so I'm going to bring that down. Now be careful here. I now see an x squared t right here. And I know it's in a different order, but I also see one right here, x squared t. I have a -1 and a +1. I want to encourage you to not put stuff like this. Now you can if you want, and that's fine, but it's really unorthodox. You don't put 0x squared t. It just simply means that these two terms canceled each other out. Okay? But if you want to put the 0, that's fine. Now I've got a term that's xt squared. Here's another one, xt squared. One's a +1, one's a -1. They're going to cancel each other out. And the only term left is t cubed. And I really have no other term to combine with t cubed. So there we go. Let's move on to number 33. Okay, I've got a 5a. I'm going to move this down just a bit so we've got some room up top. All right, I take 5a times 2a. That would be 10. That would be 10a squared. And then 5a times -3 is -15ab. And then 4b times 2 would be +8ba. And then +4 times -3 is -12b squared. Now, the only like terms I see would be this term ab and this term ab. They're like terms. So I'm going to go ahead and combine those. And when I do, I get -7. Now, I don't care if you put A, B, or BA. Usually, you list it in alphabetical order, so it would be A, B. And then bring down your first term, which is 10A squared. Bring down your last term, which is -12B squared. Okay, so there we go. Let's go back a page just real quick. Here we multiplied a binomial times a trinomial. Now we multiplied a binomial times a binomial. And now we're not going to multiply anything. Notice we have a number 34. We have a really long parentheses and then minus another really long parentheses right here. Now what I taught you guys to do when you're not multiplying but you have positives and negatives in front of the parentheses, I said if you have a positive sign in front of the parentheses, which you do here, just leave everything alone. So 5xy to the 4th minus 7xy squared plus 4x squared minus 3. And then what I taught you is if you have a negative sign in front of this parentheses, what you do, just go through and change all the signs. So this -3 would be a +3 xy to the 4th. This +2 would be a -2 xy squared. This -2 would be a +2y. And this +4 would be a -4. Now, let's look for some like terms. I have an xy to the 4th. Here's one, xy to the 4th. +5, +3, that would be a +8 xy to the 4th. Cross off of this term, cross off of this term. Now I have an xy squared term. And here's one right here. So a -7 and a -2. That would be a -9xy squared. Cross off that term, cross off that term. Now I've got an x squared term. I see no other x squared terms up here at all, so I'm going to put a +4x squared. Next I see a -3, which is a constant term, no x's with it, no variable, and I also see down here I have a constant term. So -3 and -4 are like terms, so I'm going to put a -7 and then bring down your +2y. And that's it. There are no other like terms to combine, and so that's all that you had to do. All right. Now for numbers 35 through I think it's 45. Again, thanks for your patience. I don't have this memorized. For the rest of the assignment, 35 through 45, it's all going to be factoring. And so let's do a bunch of factoring. Here we go. All right, number 35. First of all, we always pull out what's common. There's nothing common I can pull out in all four terms. Next, I taught you when you have four terms, factor by grouping. That means you pull out what's common in the first two terms. What's common in the first two terms is x squared, left over with an x and a +2. Then I've taught you when you pull out what's common in the second two terms, If there's a negative sign here, which there is, then you always pull out a negative. And now what numbers go into 3 and 6 evenly, or what number does? 3. Notice there's no x's you can factor out, so you're left with, let's see, negative 3 times x would be negative 3x, and negative 3 times positive 2 would give you a negative 6. So there we go. Our parentheses do match, and we write our matching parentheses one time. And we're left over with this right here. All right, that's called factoring by grouping. That's number 35. Moving on to number 36. Always pull out what's common. 3 is the largest number that goes into both of these numbers. I have 3 a's here and 1 a here, so I can pull an a out of both terms. And here we go. 3a times 4a squared is 12a cubed. And then 3a times 9b to the fourth would be negative 27ab to the fourth. Now, after you put out your 3a, notice you're left over with a binomial. So you say to yourself, do I know the square root or the cubed root, either one of both of these terms? Well, yes, the answer is you know the square root. You know the square root of both of those terms. So we're dealing with perfect squares. When dealing with perfect squares, the first term has to be positive, and it is, and the second term has to be negative, and it is. So if that's the case, then we're simply ready to go ahead and put 2 little parentheses. The square root of this term is 2a. So I'm going to write a 2a and a 2a. The square root of this term is 3b squared. So I'm going to write 3b squared and 3b squared. Make one positive, make one negative, and there we go. We're finished. All right, let's take a look at number 37. Now, notice here they're trying to confuse you. We never really went over this in class, but to me it's common sense. You want to write your trinomials in standard form. So you do want the highest exponent first, x squared, then your x term, and then your constant term. So let's go ahead and make that adjustment. I know I did not mention that in class, but really that's pretty common in factoring. Now step 1, pull out what's common. There's nothing common you can pull out. So next you say to yourself, am I left over with a binomial or a trinomial? Well, I'm left over with a trinomial with a lead coefficient of 1. Those are the easy kinds. So I'm going to have to list out all the multiples of 144. That's a lot, but right off the bat I think of this. I mean, a positive 12 times a positive 12 is 144. And if I combine these two 12s, I get 24. So the factorization is actually pretty simple. It's going to be x plus 12, x plus 12. And by the way, that is a fine answer. Leave it like that if you want to. But some students like to write x plus 12 like this with a power of 2, and I have no problem with that either. It's totally acceptable. All right, let's take a look at number 38. Now, let's pull out what's common. Notice the 9, the 35, and the 4 have no common factors, but I can pull an x out. So if I pull an x out, I am left with 9x squared plus 35x minus 4. Now, you're left over with a trinomial on the inside. Unfortunately, if you'll look, I do not have a lead coefficient of 1. I have a lead coefficient of 9. So we have to do this the long way, where we take this middle term and we rewrite it with 2 terms, and then we have 4 terms down here, and then we factor by grouping. So here we go. I have a 9 here. In my head, I take 9 times negative 4, and I would get negative 36. So I'm going to find the factors of negative 36, or list them out. But I'm going to save a lot of time here. I'm going to go ahead and tell you right now, a negative 1 and a positive 36, if you multiply those, you'll get negative 36. If you combine those, you will get positive 35. So I'm going to go ahead and forget this x and put it down here in my final answer. And I'm going to take this 35x and I'm going to rewrite it with 2 terms, a negative 1 x and then a positive 36 x, and then bring down your last term, which is a negative 4, and bring down your 9x squared. Now let's factor out what's common in the first 2 terms right here. I can pull out an x, and so I'm left with 9x minus 1. Here I can factor out a 4, so I pull out a 4, and I'm left over with 9x minus 1. So your matching parentheses, you write those one time, and then you're left with x plus 4 for your last parentheses. All right, that's number 38. Moving on to number 39. Now, there is nothing common I can factor out. So then I say to myself, do I have a binomial or a trinomial? I have a binomial. Okay, fair enough. Do I know the cube root or the square root of these two terms? Well, you know the cube root. You're dealing with perfect cubes. So with perfect cubes, you have to have either a positive and a negative or a positive and a positive. I have a positive and a negative, and we know by now when dealing with perfect cubes, you put a little parentheses and then a really big parentheses. Now, the cubed root of 8x cubed is 2x. Now, how did I get that? Well, 2 times 2 times 2 is 8. So the cube root of 8 is 2. And x times x times x is x cubed. So the cube root of x cubed is x. Now you also take the cube root of this term in your head, and the cube root of 1 is 1. Whatever this sign is here, you always bring it down and put it right there. All right. Now I'm going to put 3 blanks over here and try to fill these 3 blanks in. Okay. So first of all, in this first blank right here, I'm going to put, I take this term here, whatever it is, and I square it. So really in my head, I'm saying 2x times 2x, and that would be 4x squared. And then for this blank right here, what I'm going to say to myself is I take this term, which is 2x, and I take this term, which is 1, and I multiply them together. So 2x times 1 is 2x. And then for this last blank right here, what I do is I take this last term, which is a 1, and I square it, so 1 times 1 is 1. Now, whenever this sign here is negative, which means I put a negative sign right here, all the signs over here are positive, always. So positive, positive, positive. For your test, you're going to have those sign sequences memorized. I will not give those to you. All right. Moving on now to number 40. Number 40. Okay, notice right away we have a binomial. I cannot think of any numbers that go into to 27 and 125 evenly, and I cannot pull any x's or y's out. So I say to myself, do I know this, the square root or the cube root of these numbers? Well, I know the cube root of both of those, okay? So I'm going to put a little parentheses and then a big parentheses. Now, in your head, take the cubed root of this term. And if you do that correctly, you should get 3x squared. 3 times 3 times 3 is 27. X squared times x squared times x squared is x to the 6th. Now take the cube root of this term in your head. If you do that correctly, you should get 5y squared. 5 times 5 times 5 is 125, and y squared times y squared times y squared is y to the 6th. Now this positive term right here, you put that right there, so the positive term goes there. And now how do you get this first blank right here? Well, you square this. You take this term here and you square it. 3x squared times 3x squared would be 9x to the 4th. How do you get this middle term? Well, you take 3x squared and 5y squared, and in your head you multiply them together. 3 times 5 is 15, and x squared times y squared is x squared y squared. And then how do you get this last term over here? Well, you take 5y squared and you square it. So 5y squared times 5y squared is 25y to the 4th. Now, whenever this sign right here is positive, then the sequence over here is positive, negative, positive. All right? And that's number 40. Moving on to number 41. Now, always pull out what's common first. I'm going to factor out an x, or a 6, and I'm left with x cubed plus 8. Now, you're left over with a binomial, so you say to yourself, do I know the square roots or the cubed roots? Well, I know the cubed roots of these two terms, so I'm dealing with perfect cubes. Whenever you're dealing with perfect cubes, you put a little parentheses and then a big parentheses. In your head, take the cubed root of this. The cubed root of that term would be x, and then take the cubed root of this term, and the cubed root of that term would be 2, and then bring down this sign right here. In this case, it's positive. And now, how do you get this first blank right here? Well, you take this term and you square it. So x times x is x squared. How do you get the next term right here? Well, you take this term and multiply them together, so x times 2 is 2x. How do you get this last term right here? Well, you take this term right here and you square it, so 2 times 2 is 4. Whenever we have a positive sign right here, the sign sequence over here is positive, negative, positive. And there we go. Moving on to factor number 42. Now, number 42, notice, has 4 terms, 1, 2, 3, 4. So we're going to factor by grouping. So we're going to first of all ignore these last 2 terms right here, and we're going to pull out what's common in these 2 terms. I can pull out a 4 and an x squared, so I'm left with x minus 1. X minus 1. Now I come over here, notice there's a negative sign right here, so because of that I'm going to put a negative sign, and I can factor out a 9, and I'm left with x, negative 9 times x is negative 9x. Now be careful on this next one, it would be a negative 1, because negative 9 times negative 1 does give you a positive 9. And notice your parentheses do match, so you have x minus 1, 4x squared minus 9. Now you think you're done, and you're not. See this binomial right here? You cannot factor this any further. We do not know the square root or the cube root of these 2 terms. However, we know the square root of this term, and we know the square root of that term, so this binomial right here can be factored down some more. In fact, when you're dealing with perfect squares, the first term has to be positive, and it is. The second term has to be negative, and it is. So for this parentheses right here, I'm going to put 2 little parentheses. And here we go. I guess I can go ahead and bring down my x minus 1 real quick. In my head, I'm going to take the square root of 4x squared. That's 2x and 2x. And then in my head, I'm going to take the square root of 9. That's 3 and 3. Make one positive, make one negative, and now we're done factoring. Be sure and look for those extra factorings on the test, okay? All right, number 43. There is nothing common that I can pull out, and notice, unfortunately, I have a lead coefficient of 9, so I'm going to take 9 times 25. I'm going to put that right here, whatever I get out, and that's going to be 225. Now, if you want to list out all the factors of 225, it's going to take you a while, but I'm just kind of thinking in my head, you know, 3 goes into 225, excuse me for yawning, 3 goes into 225, 3 times 75, 4 goes into it, no it does not, 5 goes into it 45 times, and the more I thought about it, I realized, hey, 15 times 15 is 225, and if I put 2 negatives, then a negative times a negative is positive 225, and if I combine those 2, I get a negative 30. So it dawned on me then, my 2 terms for negative 30x would be negative 15x and negative 15x. And now bring down your last term, which is positive 25, and bring down your first term, which is 9x squared. And now we have 4 terms, 1, 2, 3, 4. And we know how to factor 4 terms, we group. So let's factor out what's common in the first 2 terms. A 3 goes into 9 and 15. You can also pull an x out. So we're left over with 3x minus 5. 3x times 3x, 9x squared, 3x times negative 5, negative 15x. And then here, notice we have a negative sign right here, so we're going to pull out a negative sign. And what goes into 15 and 25? Well, a 5 does. And you're left with 3x minus 5. Because negative 5 times 3x is negative 15x, and negative 5 times negative 5 is positive 25. So you write your matching parentheses once, 3x minus 5, and then you're left over with, for the other parentheses, 3x minus 5. And we're moving right along, number 44. All right, now there's nothing common. Oh yeah, I can plot a 3. So I'm going to factor out a 3. That'll make it a little easier. So I'm left with 6x squared minus x plus 2. And now this 3, I'm going to go ahead and cross it off and put it way down here at the bottom for my final answer. Now, look what you're left over with. A trinomial with a lead coefficient of 6. So I take 6 times 2 in my head, and I put the product right over here, which would be 12. And now I've got to list out factors of 12 in such a way that I get a positive 12, but when I combine, I get a negative 1. Well, how about this? A positive 3 times a negative 4 is negative 12. And if I combine those two numbers, I get a negative 1. So I'm going to take this middle term, and I'm going to rewrite it. I'm going to put a positive 3x and a negative 4x. And then bring down your positive 2, bring down your 6x squared. Now we have 4 terms, 1, 2, 3, 4. So we know what to do. We factor out what's common in the first two. Well, 3 goes into 3 and 6, and I can pull 1x out of my 2 terms. So I'm left with 2x here and plus 1 here. 3x times 2x, 6x squared. 3x times 1 is 3x. Now notice I have a negative sign here, so I'm going to put on a negative, and what goes into 2 and 4? Well, 2 does. And I'm left with 2x plus 1. I think, let's see, negative 2 times 2x is negative 4x, and negative 2 times 1 is, ooh, that would be wrong, isn't it? Let's see if I made a mistake here. I think I did. Let's see. I did. How sad to have to go all the way back to the beginning. Wow. I don't mind looking dumb or making mistakes. I just hate to waste the time on the videos for you to watch wrong math, so I apologize. But I'm sure it'll happen plenty of times before the year's over. Okay, let's just real quick do this. Okay, we pulled out a 3. I think I know what my mistake is. And that leaves me with 6x squared minus x plus 2. And then I took 6 times 2, which is 12. So I'd list out all the factors of 12. Now it has to be a positive 12, and that's where I messed up. Notice I had a positive 3 and a negative 4. Well, if you multiply those, you get a negative 12. You don't want a negative 12. I don't think you can factor this any further. I'm going to glance in my book here and see if I have an answer. Yeah, I'm right. You cannot factor this any further. Watch this. If you list out all the factors of 12, and it's a positive 12, so a positive, you want positives and negatives grouped together. Do you see one group that adds up to a negative 1? No, not one group adds up to a negative 1. So all that means is this is as far as you can go. You can't take it any further. Good problem. I like that. That's good. All right, let's go ahead and take a look now at number 45. Number 45. Well, there's nothing common I can factor out. There's no whole number, nor is there an A and a B in all of the terms all the way across. So the next thing I would say to myself, I would notice if there's nothing common to factor out is, what am I left over with? Well, I'm left over with a trinomial that has a lead coefficient of 1. So that's pretty much the easy type. I can list out all the factors of negative 6. So I'm not going to take time and do that. Notice I want factors of negative 6, like a positive 2 and a negative 3. So if you multiply those, you get negative 6. But look, if you combine those two, you get a negative 1, which is what we want right here. Okay? So I'm going to go ahead and put my 2 parentheses. Now be careful. Usually we have just an x squared here for our first term. We have an a squared, b squared. So if I have an a squared, b squared, that means I want to put an ab here and an ab here, because if you were to multiply this back out, you're supposed to get what you started with up here, and ab times ab would give you a squared, b squared. And then next, I'm going to put positive 2 and then negative 3. And that's it. If you were to multiply this back out, you would get what you started with up here. All right? I hope this has been helpful. It's been long for me. I'm tired. I'm actually going off to bed now. So hope this helps you a little bit. And be ready with your questions when you come to class. All right?